Hey everybody, Dr. Nelson here. This is a video about the roots of quadratic functions. So, what exactly is a root? Well, let me show you. So here we have the function y equals x squared minus 2x and minus 3. We know it's quadratic. And one of the roots is right here. So you put a little dot right there. And this one actually has a second root, which is over here. All right, so what do these 2 points have in common? Okay, well, they're both x-intercepts. So one characteristic of a root is that it's an x-intercept. All right, so in this case, there's 2. All right, and when you have an x-intercept, that occurs when the y value is 0. So the y value must be 0. All right, and the big idea of this is, so when the y value is 0, okay, these locations will actually give you the solution, okay, to the value of x. All right, so here we have a value of x of -1 and y is 0, so -1 and 0. And here we have an x value of 3 and 0. So if I plugged in -1 in here for x, well, -1 squared is 1. And then minus 2 times -1 will give us a plus of 2. And then minus 3, and 1 plus 2 is 3. And 3 minus 3 is 0. All right, so -1 is a solution for the function when y is 0. Now let's do the same thing for when x is 3. If I plug in 3 here, 3 squared is 9, and 2 times 3 is 6, and I take it away, so 9 take away 6 is 3, and take away another 3 gives us the 0 again. So the 3 is a solution, and also the -1 is a solution. So anytime you look at a quadratic function, if you can find the x-intercepts, those are the solutions when y equals the 0. Alright, so if you turn the page, let's take a look at some graphs. And let's see if we can figure out how many roots there are. Alright, so here we have a quadratic function. And notice we have a root here and a root here. So that means there are 2 solutions when y equals 0. Now, here we have 2 different quadratic functions. One's going upward, one's going downward. But if you notice, there's only going to be one x-intercept. I know the graph is a little fuzzy. There's one there, and there's also one right there. So that means there's only going to be one root for each one of these graphs, or one solution. Now, take a look at these. Notice these are not touching the x-axis at all. All right. So that means because there's no roots, there's no solutions when y equals a 0. So here we have 2 roots. Here these have 1 root, and these graphs have 0 roots. So what I want you to do is I want you to pause the video and try the your turn problem now. And then when you're done, hit play. You can see how you did. All right. Good luck. Alright, welcome back. Let's see how you do with this practice problem. Okay, so here again we have a quadratic function. And the first question is, how many roots does the quadratic function contain? And so again, that really means is how many times does the line touch the x-axis? And there's 2. One is at right here, which is -2. And one is at +2. Alright, so we could say that when x is -2, y is 0. And when x is +2, y is also 0. So the value of the roots would be a -2 and also a +2. So now based on that, let's determine which one of these functions is actually graphed over here. So again, we know that when y is 0, these are going to be the x values. So let's see, if I plug in a -2 here, -2 squared is 4, and 4 plus 2 is 6. And 0 does not equal 6, so we know it's not going to be that one. So we're not even going to attempt to plug in the second one. Let's plug in, say, a -2 here. So -2 squared is 4, and 4 take away 4 is 0. So that's a match. Now let's plug in a +2. So if I plug in a +2 here, 2 squared is 4, and 4 take away 4 is also 0. So we know that when we plug in a negative 2 in for x, we get 0 for y, and we plug in a positive 2 in for x, we get 0 for y. So this right here is our solution, or our match for this graph. All right. If I plugged in a negative 2 and a positive 2 for the x's here, they would not equal 0. So that would not be a match as well. All right. How'd you do?